Welcome to 1.2 part 2. In this video, we're going to talk about some identities you learned last time and some new ones you're going to need today. So first in your notes, make sure you highlight these three. So that's why I put a 3D box. You want to commit these to memory, and hopefully you have them down from last time's homework. The first new one we're going to talk about will be right here. Tan of theta is equal to sine of theta over cosine theta, which would then imply that cotan theta must be the reciprocal cosine over sine of theta. And again, you're going to want to put a box on this thing. This thing is pretty important. So again, let's put a box here. This thing is super important, so you're going to want to have to really highlight these in your notes. That's fine. Okay, so 3D box, boom, boom. Perfect. Now, if you're wondering where that came from, the proof is actually pretty straightforward. I'll do it right, right above, right below actually. If you think about sine, that's just opposite over hypotenuse. Cosine is a over h. The h's cancel out, and that is your O over a. And right there, that's tangent. So pretty straightforward proof. Not the best proof, but that is basically how it's working. Now the last one we're going to need is the Pythagorean identity. That's going to be sine squared theta plus cosine squared theta equals 1. Let's underline that. We're going to need that for today. We're not going to prove it today, but just know that that's what we're going to need. Use it as a fact. And later on in our future videos, we'll prove this. You can also check out Tomo's Instagram, and he has a visual proof for you in case you're wondering. So let's do our first question here. The goal is to find the exact value of this trig expression using the identities above. So first you're going to note is look at this thing right here. You have to practice recognizing that's an identity. That's going to be sine over cosine, which now we know is tan. So rewrite it as tan 20. Tan 20 minus tan 20, look at that, 0. You're done. B, sine squared of some angle plus 1 over secant squared. Again, let's look right here. Secant is the reciprocal of cosine. So let's rewrite it. Sine squared pi over 12 plus cosine squared pi over 12. And then look at your Pythagorean identity. That's equal to 1. That's the answer. Okay, moving on. Using the complementary angle theorem. So this one is actually one of the big SAT concepts. So we're going to write big SAT concept. What we're going to need is this. That sine of 90 minus theta is equal to cosine theta. Secant of 90 minus theta is equal to cosecant theta. And tan of 90 minus theta is equal to cotan theta. In case you want to see the proof, check out Tomo's Instagram where he proves it, so you can see his visual proof for that one. So we're just going to use these. So if you want to change sine using this complementary angle theorem, notice how it lines up with cosine, so let's write cosine. It's called complementary, or I call these co-functions. In your notes, we often refer to them as co-functions, because just take the complement of the given angle. So complement meaning take it away from 90. So cosine of 90 minus 62, that's cosine of 28. There's your answer. So if I want tan of pi over 12, the co-function is cotan. We'll use pi over 2 instead of 90 because we're clearly in radians. Let's get our common denominator. That's just 6 pi over 12 minus pi over 12. That's cotan of 5 pi over 12. And notice how we're just stopping, because the question is saying use the theorem, so that's all we're going to do. So for the next two, I'll move C over there. You want cosine of pi over 4. Change that to sine. That's going to be pi over 2 minus pi over 4. And that's going to be sine of pi over 4. And finally, this last one, let's change cosecant to secant pi over 2 minus pi over 6. Be careful with your fraction work here. We just want to make sure we're accurate. So 3 pi over 6 minus pi over 6. That's secant of 2 pi over 6, which is finally secant of pi over 3. A little bit of fraction work there, so always be careful with your work. That's it. Okay, final examples. We're going to use this theorem to simplify some expressions. So students always have a hard time with this, and this is where you're going to get stuck. Put a big red star. Make the angles match. If you're ever stuck, it's probably because you're not doing this first. Always ask yourself, do the angles match? So look here, 28, 62. Do they match? Of course not. So we're going to pick one. It won't matter. I'll pick this one. We're going to change it using your cofunction. So secant becomes cosecant. Take the complement, 90 minus 28, minus cosecant, 62. And look at that. 90 minus 28 is 62. Cosecant 62 minus cosecant 62, 0. You're done. B. Do the angles match? Of course not. Let's pick one of them. I'll pick the bottom one. So let's leave the top alone. We'll make the bottom one the cofunction, which is sine. Take the complement, 90 minus 55, and let's see what happens. Sine 35 over sine 35. Look at that, they match. The answer is 1. Alright, so now try to finish the rest of the homework problems, and I'll see you on the next video.